welcome back for another VMK in the C++ series. In this VMK, I'll be discussing the explicit keyword and how it comes in very handy when working with constructors. So let's jump into Visual Studio and create a new project. I'm going to call it Explicit Constructor. It's going to be a Win32 console application, and the default settings are going to be console application with precompiled headers, and I'll click Finish. Okay, so first thing we need to do is create a class so that we can play around with it to see how it is that the explicit keyword actually works. I'm going to create a new header file and C++ file, and I'm going to call it my class. So the header file, I'm just going to move it over to the other side here, has a constructor and a destructor. So let's take this out and take a look at the default implementation. We also have a copy constructor and a overloaded operator equals. So what is it that I want to do with this class? Well, every time I initialize a new myClass object, I want to pass in a value that it will store. And I also want to keep track of how many of these myClass objects I have. So I can do that with the following. I'm going to declare a static integer, which is going to keep a counter of how many of these guys I have. I'm going to have a I value here, which is the value that I pass into a constructor. So here I'm going to have int I. And the ID value is just going to be one of these counter values, so I know which one of these class objects I have. Now inside of the CPP file, I need to allocate some memory for my integer, my class counter, and I'm going to initialize it to 0. Our constructor takes in an integer, and I'm just going to set the I value equal to whatever is passed in, and I'm also going to set the ID value equal to counter value, and then I'll increment the counter as well. Inside of the constructor, I'll display a message, and in the destructor, I'll also display a message. So if we're to build this and go back inside of the main function here, if I were to go my class, I need to include my class.h. So now here we can go my class, and the constructor needs a value. So let's say I pass in a value of 33. What that's going to do is it's going to go and construct one of these objects, increment the counter, save that inside of the variables, and also save 33. Let's also have a print function so we can show what value I have stored inside of my class object. Here I'll just declare a void print function, which is not going to change anything that's stored inside of the class. And in the implementation, we can see here that all I'm doing is calling printf and saying I is equal to whatever value is stored inside of our class. Okay, so now let's go back inside of our main, and here I can go my class.print to display 33 to the screen. So if I run this, we can see we constructed the first object with I is equal to 33. I called the print function, so it gets printed I is equal to 33. And then when it goes out of scope here, we call destroy on the first object. So everything looks fine, right? Well, it's not all right, because we do have a class here that we're passing in a parameter into. And that can be problematic if you're not using the explicit keyword. So let's take a look how this could be a problem. I'm going to comment out this print statement, and let's say I go and create another myClass object. This time I'll call it myClass2, and I'll make it equal to 512. If I go and build this, notice it builds successfully, and if I run it, it also runs completely successfully. So I constructed the first object, set it equal to 33, and I constructed the second object and I set it to 512. Now you may look at this code and go, whoa, what's going on here? How is it that my class can be constructed out of 512? Well, it can because basically we're telling the compiler that we do have a valid conversion between an integer and a myClass object through this constructor. This is completely different than if we were to do something like this. My class is equal to 400. If I were to do this and try to compile it, notice that we get an error saying that this operator equal is private. So here, this equal sign on the constructor is actually constructing it using this guy here. However, this equal sign here is trying to assign 400 to our class, which is trying to operate on this operator, but because I defined it as private, it can't do that. So if we were to move this out and make it public, like so, notice the little red squiggly disappears, and now I'm able to compile it. However, it's giving me a fatal linking error because it's saying, well, I need to use this operator, but I don't have any code that defines how to make 400 equal to a myClass object. So I need to go and write some code for this. So let's say that I go ahead and do that. A typical implementation may look something like this. We're passing in a myClass object into our operator equal, and all I want to do is take the I value that's stored inside of the class that we have here and save it inside of this new one that I'm inside of here, and I'll display a message saying we're copying a certain value from this guy to that guy there. So the value that we're copying and where we're copying it from and where it's going to. So let's go and build this and give this a run to take a look at what's going on. So notice here, we created 33, that's object number 1. We created object number 2, 512, and then here we're creating object number 3 with 400. And the way we're doing that is we basically are using the equal operator, which is going into our operator equal here. And inside of our code, let's move that over to here, we can see that we're passing in a myClass object. Well, we're getting that myClass object not from the 400, but once again from the constructor that's constructing a myClass object from an integer. So that's getting constructed for us here, and then we're copying over the value 400 from object 3 into object 1, since that's what we're doing. Object 3 was the 400 that got constructed. Object 1 was the myClass, which was this up here. Then we destroy object 3 because we no longer need it because we copied it over, and then we exit out of our scope, so we destroy number 2 and we also destroy number 1. So this is very confusing. We are basically assigning integer values into our class, and we're getting things happening for us magically behind the scenes without us really realizing it if we're not very careful. So this is where the explicit keyword comes to our aid. Okay, so let's take a look at how we can use the explicit keyword. Well, it's as simple as that. Just typing in the word explicit right in front of our constructor. Explicit is a keyword, so it will show up in blue inside of the Visual Studio Editor. And as soon as we do that, and we try to run our code, now take a look at what happens. I'm just going to do a build clean solution and try rebuilding again. Notice now we cannot convert from an integer to a myClass. So here, where we were previously able to execute this code, we're now failing. The compiler is not letting us convert a integer to a myClass object because this basically means we have to first construct a myClass object out of our integer. So we would have to first do this, myClass, and then we'd be able to make these two things equal. Same thing here, if we were to go myClass, then here notice that it lets us equate those two. So let me just do this. We can build that, and if we run it, Notice here we construct 1 with 33, we construct 2 with 400, and then we copy from 2 to 1, the 400 value, we destroy 2, we destroy 1. So this is completely valid. Now if we're to do this, notice that this still gives us an error because now what we're saying is we're trying to copy construct. This is the constructor of myClass2, but we're constructing it from a new guy called myClass, but our copy constructor is private. So if we were just to move this over here like that, then the squiggly line disappears, but now we're going to get a linker error probably. Let me rebuild. I'm surprised that actually builds. Oh, right. It's going to give us the default copy constructor, which just copies our values over, and we don't actually see the code. So if I were to go and implement our copy constructor with the comment here, we would see that it's actually copying things over. So if I declare my copy constructor to pass in a my class object, we're going to take the value of I inside of that class, save it inside of our own, and then increment the counter and save it here. Then we can print constructed this value with this guy with this value to the screen when we call this. So now if we give this a run, construct the first one with 33, and the second one gets constructed with 512, and we clean everything up correctly. So by using that explicit keyword, we're able to get around the wonkiness of being able to assign an integer to a myClass object where we shouldn't be able to. Now let's take a look at some other wonkiness that we can get if we're to remove that explicit keyword, and let's create a function where we pass in a parameter. Actually, first let me go and move this back to make it private so I can demonstrate this a little bit better. So here I'm going to create a void foo where we pass in myClass. So all we're doing is we're passing in a myClass object. We're going to print inside foo, and then we're going to print the value of the parameter that we passed into here. So then over here, let's take some of this stuff out, and we already constructed this guy with 33. So let's call foo myClass like so. You try to build this, but you can't because once again, let's try that again. It brings up an error message saying that our copy constructor is private. So we do need to have this guy out here if we want to be able to pass our class object into our foo function directly, so we're actually making a copy. So let's go and build this, run it, and give it a try, and see that here when we go and create myClass33, so that's object number 1, then we call foo, so we're going to construct number 2 with I33. Inside of foo, we have I is equal to 33, and then we destroy 2, destroy 1, and we exit. So we can clearly see that we're constructing 2 with the value of 33. However, let's take a look here what happens if we're to go foo 1, 2, 3. You would expect this not to work. Well, surprise, surprise, it does work. Foo expects a myClass object. However, we're passing it an integer, and the compiler is smart enough to know, well, I'm passing in an integer, I know how to convert an integer to a myClass object, so it's going to call this constructor for us, pass it into our function, and go on its merry way. So let's give this a try. Notice what's happening here. Well, might as well take this one out so that we don't confuse ourselves. We construct the first one. We construct the second one with a value of 123. We're inside of foo with 123. We destroy 2, we destroy 1. So even if I go and remove this, we can see we're constructing 1 with 123. We're inside foo, and then we destroy 1. So even though in our code here we don't see any references to myClass, inside of here we are constructing a myClass object from this 123 integer value because our constructor here accepts a integer value. So again, to prevent that, we can make this explicit, and by making it explicit, we automatically tell the compiler, no, there's no way that you can convert this 123 to a myClass object unless I explicitly tell you you're allowed to. So in this case, you would have to go myClass 123, and now the code will run. Without that extra myClass constructor wrapped around the 123, you're not allowed to implicitly construct our object from an integer. Okay, let's take a look at one more example of where the explicit keyword is very handy. Once again, I'm going to remove it temporarily, and let's say that I declare a overloaded operator for the double equal sign. Typically, you would want to pass in a object of the same type to your class when you're comparing, and you want to return a boolean to represent whether these two things are equal. So let's go and implement this function right at the very bottom here. I'm going to say that these two things are equal if their values are equal. So I can take c dot underscore I, and if it's equal to my own underscore dot I, then yes, they are equal. So let's go and compile that. That's fine. Now let's go try this. So if, well, I guess I need some myClass guys here, myClass 33. So that's going to construct one of them for me. And then if myClass is equal to 33, then print yes, they are equal. Else print no, not equal. So if I run this, we can take a look here to see what's going on. Well, we construct 1 with 33. We construct 2 with 33. 2 gets destroyed, and yes, they are equal. 1 gets destroyed, and we return. So right here, because we don't have the explicit keyword on our constructor, we are automatically constructing an object because we are trying to equate myClass with an integer. Again, not very intuitive. So if I had this to be 87, for instance, we see we have 33 constructed up above. 87 gets automatically constructed for us, gets destroyed, and we see that no, they are not equal because 87 is not equal to 33. So to prevent this, once again, we would go back into our class, declare this as explicit because our constructor takes in one parameter, and as soon as we do that, then bam, we can see that, well, let's go do a clean build. We no longer can run our code. It says double equal sign cannot be operated on because we have a explicit constructor. We cannot convert an integer into a myClass object. If we did want to do this comparison, we would have to explicitly say, okay, 87, I actually mean the object with the value of 87. So now I can go run the code and it will behave properly. And this is actually a lot more readable to someone who's looking at the code that's not familiar with what exactly is happening behind the scenes inside of your classes. So, general rule of thumb, if you have any classes that have a single parameter constructor, always declare them as explicit. If you don't, you're going to run into problems where your code is hard to read because you're going to be implicitly converting whatever parameter you passed into here into your objects without realizing it. And that can get you into a lot of problems wherein you do have complex programs or large programs with a lot of manipulation of data. So once again, I'm going to reiterate, if you do have a constructor in your class that takes one parameter, you should be using the explicit keyword in front of it to tell the compiler you only want this object constructed explicitly, not implicitly, and do a conversion for you. If your constructors have no parameters or have more than exactly one parameter, then you don't need to use the explicit keyword. So for instance, if you had myClass int I, int j, None of this is a problem because, let me take this out and actually modify my constructor here to take a j parameter. Notice that none of this is now a problem because you cannot do something like this. One, two, three. We cannot have this equate operator convert 87 to a double parameter construction of your class because your code doesn't tell you how to do that. Nor can you do things like my class is equal to 71, 78. Again, you cannot do this because the compiler has no idea how to take a single parameter and convert it into my class object. However, one thing you do need to be very careful of is if you have default parameters. So here I have a constructor which takes in two parameters, but as soon as I make the second parameter a default parameter, then once again I do run into that same problem we had before, where now I can construct something with just one parameter. So here, let's take this out. Let's take this out, and notice that if I go and do a clean on this, the compiler has absolutely no problem with this code. It's basically saying, okay, I'm going to construct a object here using 78 as the first parameter, using 2 as the second parameter, and go on its merry way. And that's exactly what it does. So to prevent that, you do need to specify this as explicit as well. So anytime you have a constructor that takes in one parameter or takes in multiple parameters, but all except for the first one are default parameters, you do need to specify it as explicit to make your code readable. Now, is that it? Well, if you're taking a look at this class constructor here, you'll notice I do have one other constructor that is not defined explicit, and it does take one parameter. Let's go and change this back to how it was before. I have the copy constructor right here. He takes one parameter. Should I make this explicit? Well, you can try. I wouldn't recommend it though, and let me tell you why. So let's take out that explicit keyword in front of our copy constructor, and let's create a new function. I'm going to call it goo, and it's going to return to us a my class object. So inside of the class, we're going to create a object called goo class, and I'm going to define it as having a value of 54321. Inside goo, we're going to print, and then we're going to print that value here, and then we're going to return the myglue class. So outside of here, I'm going to have something like this, goo. So all I'm doing is I'm saying, okay, goo, please go ahead, create a class, and then copy it out for me so that I have it right here. If I run this and take a look at the output, oh, I guess I should compile it first. What am I doing wrong here? It says, oh, I forgot to change this here. Okay, so going back into our code, Control F5, notice what's happening here. I go and construct one inside of the goo function with a value of 54321. Inside of goo, I print that out, and then I go and construct a second guy with a value of 54321. I destroy one and I destroy two. So the return value here is getting returned as a copy. So that's where that second guy is coming from, and it's getting passed into the value of my class. So that's very handy to do. You will want to have functions that return objects of your own type. As soon as we go and make your copy constructor explicit, notice what happens. We lose the ability to do that. Now that's can be quite the headache. You can get around it by writing your function calls to get around that problem. Like for instance, if I were to create my own class called who, where I pass in my class as a reference, then inside of here I can go and create that same value, 54321, print it inside of who, print the results, and then when I return out, then here we would have so let's say here I declare it as 0, and then I pass it into who, so who should change the value to 54321, and here we can go my class.print. So if we run this, we can see, oh, I have the explicit keyword here. Let's take that out. Oh, and my copy constructor has the explicit keyword for goo, so let's just comment this out so it's not complaining. My result is not defined. Oh, that's a typo. Should be like that. Okay, so let's take a look at what's going on here. Inside of here, we're constructing one with a value of 0. Then we're going inside of the who function, and inside of the who function we're constructing the second one with 54321, and then we're copying over the value from 2 to 1. We destroy 2 after we do the copy. Inside of who we print the value, we destroy 1 when we exit out of here, and we return. So we're still able to get my class to construct inside of a function, but to get out of that function with that same value, we need to be able to pass the value in. So we are able to get around this in one sense. However, in another sense, this is a big headache to work with because some functions you may not be able to convert directly over this way. So you won't be able to find a direct mapping if you do use the explicit keyword. So make sure you are aware of the limitations of using the explicit word with your constructors, especially when you're using copy constructors. I wouldn't recommend using explicit on copy constructors, but every time you do have a constructor with a single parameter or a constructor with multiple parameters, but all except for the first one as being default, make sure you do use the explicit keyword. So I think that's all I wanted to show about explicit constructors in this VMK. So if you have any further questions about explicit constructors, feel free to go on down to the forums by clicking on the thread beside the VMK of interest and post your questions there.